Today in this video, we are going to have a first lesson or a quick introduction of oscillatory motion. So before going to oscillatory motion, let me tell you, what do you mean by a motion? We have learned right from the beginning of the mechanics that there are two kinds of positions like rest and motion. Rest is something that body doesn't change its position with respect to time and space, where motion is something where a body changes its position with respect to time and space. So what do you mean by motion is? There is a change in its position with respect to time and space. As we have learned in mechanics, there are three different kinds of motions that we are talking about, right? So, what are the types of motions that we have? There are three types of motions, as I told you. One is translatory motion. So, what do you mean by a translatory motion? If all particles of a body are having a similar kind of a motion, I moved this body like this. So each particle of the body is moving in the same way. Then that kind of a motion is called as a translatory motion. If not, I can consider a particular point inside at the middle, which is called center of mass, and we study the motion of that body as the motion of that particle who is there at the center of mass, or even sometimes you can call it like center of gravity. Well, that's a translatory motion. That's where we have learned one dimensional motion, two dimensional motion. We have applied Newton laws of motion, friction, all these things we have discussed there. Then there is another kind of a motion called rotational motion. The simplest version of that is a circular motion. So if a particle is moving about an axis, around an axis, a fixed axis, where it will have a torque, where it will have a say angular displacement, angular velocity, angular acceleration. We have discussed a whole lot of this in a chapter called rotational dynamics, like moment of inertia also plays an important role there. That part is called rotational motion, rotational dynamics. I'm not going into lots of details of all that just because we are talking about the other topic, right? So the third kind of a topic that what are we talking right now is oscillatory motion. Our chapter. We'll talk about this in detail. So, what is an oscillatory motion? If a particle is having a to and fro motion, so it's moving about a point like a pendulum. Like if you consider a pendulum, this is how a pendulum looks like. It will have a to and fro motion like this in a watch, in a wall clock, right? A old kind of wall clock. So, oscillatory motion is simply to begin with, it's a to and fro motion. It has to move front and back. So before going into an oscillatory motion, we shall tell you about a term called something like a periodic motion. So what do you mean by a periodic motion? The name itself tells you it is periodic. It repeats at regular intervals of time. So this oscillatory motion is a periodic motion. It goes and comes back, right? So oscillatory motion is a periodic motion, but be careful that all periodic motions are need not be oscillatory. Say for example, Earth revolves around the sun, revolves around. It is a periodic motion, but that's not a to and from motion. That's Earth is actually moving around the sun. So that's a kind of a rotational motion, right? So and similarly, I go to office every day and come back, right? Like there are so many kinds of motions who are periodic but not oscillatory. So be careful. I want to tell you one point by saying this. Here is what all oscillatory motions are periodic. They repeats at regular intervals of time, but not vice versa. Be careful, but not vice versa. That means all periodic motions need not be oscillatory motion. Simply like rotation of the earth is a periodic motion. It repeats at a regular interval of time, but that doesn't mean that's an oscillatory motion. So, what's the basic condition for an oscillatory motion is it has to be a to and fro motion. So, once it is a to and fro motion, there are some other conditions it need to satisfy, and we are ways of studying it. Among the ways that we study it, we study one kind of a motion called something like a simple harmonic motion. So it's a simplest kind of a oscillatory motion. So it has three terms inside it. It is a simple harmonic motion. You know the meaning of motion. There is a change in its position with respect to time and surroundings. What do you mean by harmonic? Let's talk. What do you mean by harmonic? Uh, if it repeats between two values, say for example, you have learned in trigonometry there are two kind of functions like a sine function, cosine function. The values of them always varies in between -1 to +1. Either it is a sine function or a cos function. These two functions are called harmonic functions, and we do represents a lot of this oscillatory motion in terms of sine and cos function, but not a tan function, simply because tan goes to infinity. It is not going to repeat back, it's not going to come back, it just goes, that's it. It never comes back. So tan is not an oscillatory function simply. Tan cannot be used to represent oscillatory function simply because its value is never coming back. Whereas sine and cos always moves in between -1 and +1. So we can use them in representing this harmonic motion. And there is another kind of a motion called something like a simple harmonic motion. So for a motion to be in a simple harmonic motion, it has to satisfy certain conditions. So what are the conditions are like to call it like a simple harmonic motion? Number one, it has to be oscillatory. Number two, its displacement is directly proportional to the acceleration of that motion. And there is a third condition. This displacement and acceleration shall be in opposite direction. So you may not understand everything that I said in the last two statements, like direct acceleration directly proportional to displacement, and they shall be in opposite direction. But we will explore and we will derive so that you will understand what you mean by actually that. So maybe uh, too hurry to define that simple harmonic motion. We will define it further as we progress further. So next time, what do we do is we will actually take an example and then explain how does this works right in the next video coming. Right. Thank you for watching.